Okay guys, so as I said in the previous video, we just dive into HaloArenes preparation first. Okay, so arene is just basically anything with a benzene group, okay, like benzene ring or whatever, aromatic benzene ring. With that, if you have some halogen attached, it's a haloarene. So just quick examples, you can have chloro, fluoro, bromo or whatever iodo benzenes. You can have something like an alkyl chain and a chlorine here. Anything works. Okay, so these are these are haloarenes. Okay. So now we're going to start talking about the methods of preparation. And the first one you guys should already know because you guys learned this in 11th is electrophilic aromatic substitution, right? So if you guys remember, chlorine, FeCl3 anhydrous. This is halogenation. You're going to get what? Right? And you guys know all the rules, right? Meta directing, ortho-para directing, all that stuff. The electrophile here is what? Electrophile is Cl plus. What does that happen? Fluorine, basically Cl, FeCl3 is electron efficient. You have lone pair coordinates with FeCl3. Like that. You get Cl, FeCl3, positive charge. Right? So then what happens is, I can write it like this, FeCl4 plus. The plus is actually on chlorine, but we just write it like this. Basically what happens is, this bond will break, you get chlorine plus. Chlorine plus, since this is plus, this is an electron rich region, it's going to attack the benzene ring, forms the aluminium ion, and then the rest is history, right? So that's basically the first method, the easy method of preparation of HaloArenes. Okay, the second method is actually pretty time consuming to explain. So there are a lot of things which I will try to explain, but generally people take for granted. So basically, if you have an amine, right? And it's okay if you guys haven't heard of amines because I don't think I had heard of amines in 11th. So amines, if you have an amine, right, which is basically an NH2 group, and there's a very famous reaction, a specific reaction of amines, which is if you react this with NaNO2. Sodium nitrate, HCl, in very cold, ice cold conditions. Right? You got to write ice cold, let's say the keyword or something. You get benzene disodium chloride, okay? Which is basically like this. So this is basically a very famous reaction, and the reaction is a named reaction, it's called diazotization. Because this is a diazonium group. Right, benzene N2 something is a diazonium group. So this reaction is called diazotization. Why? So let me just tell you a lot of quick points. Ice cold because your major aim here is to form nitrous acid, right? NaHNO2, and actually the true aim is to form this nitrosonium ion. Okay, this is your aim. This is what's actually going to react with this guy in a log mechanism to form benzene disodium chloride. So your basic aim is to form this. You form this from this. This guy is unstable at high temperatures. You can't even hold him like you can't even store him in a beaker at like room temperature. So instead you use these two which will react at ice cold temperatures to give you this. So we call this in situ preparation. If you guys remember your 10th geography, I think alluvial soil, black soil, whatever. One of them was called in situ soil because I think it's formed in the same region where the rocks are, something like that. In situ means at the same place, right? C2 means location. So in situ means it's formed at that location. HNO2 is formed at that location. Okay. So that's why it's ice cold. That's why you got Na and HCl because HNO2 is highly unstable at normal temperatures. Okay. So you'll actually do this reaction in your 12th practicals, right? You will do diazotization. You will do it. This compound is called aniline. Okay. So you got to start learning some common names right now. So aniline, this is what it's called. So that's one thing. The second thing is this guy here is what we call a synthetic reagent. Okay. So synthetic reagent means you can prepare almost anything from this guy. Okay. You can prepare a lot of things from benzene disodium chloride, as I will show you. So basically this is all you need to know. Okay. You need to know you got NaNO2 HCl, ice cold temperatures. It's to form actually HNO2. Actually, to form nitrosonium ion. This is called the nitrosonium ion. NO plus, right? So that's that. You get benzene dioxide chloride N2Cl. So now let's delve deeper. Once again, I'll be explaining things right now which are a little out of your syllabus, but hopefully will help you to remember this reaction without any snag. So basically, you got this structure, right? H2, and I told you that you need to write this for your ion. How that's prepared, don't worry. That's also actually a mechanism. There's also a mechanism for that. But if you just don't worry for a second, then you can actually derive the structural formula of benzene dioxide chloride, because this has a lone pair, positive charge. Right? You plonk, nothing happens because it's a positive charge, everybody's happy. So you'll get, I'm going to replace this in many books. This benzene attached to something, right? Is replaced by pH, phenyl. Okay? This is a phenyl group. So phenyl and H2. This guy lost the lone pair, so plus charge on him. N will bond. This guy gained electrons, so plus charge got neutralized. This is the first step. I can do a minus H plus, right? Rather than at least. In fact, I can do a minus H plus in such a way that let me write like this: NH and then another H, right? So what I'll do is, in fact, write it a little better actually. So what I'll do is I will try to remove H plus, okay, such that this bond plonks here. This gets a negative charge, and negative charge and the hydrogen interact, okay. So what I said was very fast. Let me say it again. I'm going to remove H plus, okay. So let me try step by step. What happens is H plus is removed, okay. So now I have H plus in solution or in the place. So I got H plus here. Right? This bond is now useless, it doesn't know what to do. It can either neutralize the positive charge or go here, it does not matter actually. I will just choose the bond to come here, okay? So maybe the bond comes here. If the bond comes here, this nitrogen gets 4 valency, that's not possible, only 3 is possible. So this bond will jump on top of oxygen. Oxygen gets a negative charge. Oxygen negative H plus, they're going to combine together to form OH, right? So you get OH. Then what happens? Similar thing, I can do the same thing again. So what I do, I will do the same exact mechanism again, okay? What I'm going to do is, I'm going to take this hydrogen away, minus H plus, this will go away. This bond has to come here, so it forms triple bond. Nitrogen again has 4, doesn't know what to do. Now this is, in fact, let me do this. See, I'll show you one of this and one of that. So I told you, right, you can either shift the bond between nitrogens, or I can put the bond to neutralize the positive charge, right? So let's say I neutralize the positive charge this time. This positive charge goes away. There is H plus in solution. You guys know this famous thing, right? Oxygen, OH and H plus will form OH2 plus. Good leading group. So OH2 plus. Right? Now this is a good leading group. Nitrogen will say, you know what? Away with you, and it's going to take this lone pair, right? Which it got. It's going to plonk it here. Why is it going to plonk it here? Because now it's forcing this guy to get away with this water, okay? It plonks it here so that nitrogen has no choice but to part with this bond. So this bond jumps onto this guy, water is free, and you get this, right? And this, and there'll be a Cl minus, because over here an NaHCl, so it'll be a Cl minus. So this is basically an ionic compound. You can see that this is basically benzene ring with an N triple bond N, positive charge, and Cl minus, which is what I wrote as benzene N2Cl. Okay, so this is how this is formed. If you, in case you guys want to remember, the reason why this is such a good reagent is because you can see that there is an N triple bond N with a positive charge, right? And remember we talked that nice molecules love to escape really fast. Nitrogen is a very nice molecule. So nitrogen gas is a lovely molecule. It loves to, you can just run away, right? Because, and you only have the triple charge, triple bond made for you. So N triple bond N, the positive charge. So now I can take this. This is the first step. You might be asking me, why are you doing such a pointless step? I do not see any HaloArene preparation here. The interesting thing is that now I can remove this guy any time I want. If I can just do something about this positive charge, right? Nitrogen will just leave automatically. It just loves to leave. Okay? So what will happen is, if I take some random HX right now, okay, some halic acid, and like people generally customarily take CuX along with that for better reactivity and stuff. So this is a catalyst. Anyways, I'll get X minus. Again, nitrogen positive charge. This carbon is going to be highly electron efficient. X minus attacks. This bond jumps on top of this guy. So you get nitrogen plus halic benzene, right? So X can be whatever in the fluorine, chlorine. It can be fluorine, it can be bromine, chlorine. Iodine also will see another thing with that. So just be calm. So basically you have HI, right? Sorry, HX. The X minus will come and attack, and this happens. So you get finally nitrogen plus halic benzene. Okay. This reaction is called the Sandmeyer. It's called the Gatman reaction. Sandmeyer is just instead of CuX, you just take Cu, copper powder instead. Take copper powder is Sandmeyer reaction. Okay, so those are two things you need to know. You do the same thing except in case of for iodine you use Ki instead of HI. Okay, the reason is HI is a strong reducing agent, so it will form iodobenzene, and then it will take it back and reduce it to benzene, so it becomes pointless. Okay, so instead you use Ki, which just gives you iodide ions instead. Okay, so remember this that most probably in the test paper if you see anything related to why is HI not used, just write reducing agent will probably get marks, because ICSE is all about keywords, right? So just in case you do not know what's going on, just write reducing agent will probably get marks. Okay, so that's one more thing. So yeah, it creates iodobenzene, but then it reduces it back to benzene, so there's no point in there. Okay, so that is basically the first part of preparation of HaloArenes. We're pretty much done actually. HaloArenes, not many ways of preparation. Now one more method, for example, fluorobenzene, right? I told you do not use HF because it's a weak acid. So instead what we do is, we do the same steps to get diazole. From now on I won't write N2Cl, okay, I'll write this structure so that it's easier for you guys to see. So you get benzene diazonium chloride, and instead of reacting it with whatever copper powder and stuff, you react it with, in fact you do the reaction itself, you have NaNO2 HCl, right, and you also add HbF4. HbF4 is fluorochloric acid, okay. So instead of getting Cl minus, here you will get instead of Cl minus, you will get BF4 minus. Right? Instead of HCl, you have HBF4. NaNO2, same thing. Right? Again, ice cold, all that. Okay? Once you get that, all you gotta do is heat this compound, and you'll get BF3. This one balance stuff now. You got charges will be balanced anyways. You get a BF3 plus a benzene with a fluorine plus nitrogen. Nitrogen is always there because this bond will easily break, giving this. In fact, the phenyl cation is highly unstable. Okay, this is highly unstable, but this bond is so weak. Okay, so weak because nitrogen just wants to get rid and just be free, that there are actual mechanisms where we propose this step, where the bond just breaks and you get this. Okay, so that's how much of a great leaving group nitrogen is. Okay, that's something you want to know. So always never, please never forget to write nitrogen. And I think since school, you're probably obsessed with the umpire also. But that's basically it. Okay, so we have pretty much covered almost all the methods of preparation of HaloArenes. Okay, so let me just go back and look whether there is something I missed, and then we will move on to the next one. Okay, so see you guys in the next one.